Hello there. In this video, I'm going to be discussing an external powered USB hub, 3.0 specifically, and the purpose of how it's being used, transferring 5 gigabytes per second or more bandwidth, how it actually transfers. I see a lot of people advertising on YouTube about the hubs, and they don't mention that that's a shared transfer of bandwidth. Then I'll be talking about specifically how will, when it comes to gaming, that's mainly what this video is about, use of it with gaming. How will it affect your live streaming, if at all? How will it affect your recording using software while you're gaming, if at all? And also, if you use an external SSD hard drive, and basically the realities of using USB ports. So basically, when you see USB port hubs advertised on the amount of gigabyte per second bandwidth, that is a shared bandwidth because you're connecting multiple devices, or depending on what you're connecting with your USB port, that is sharing that bandwidth. So if several devices are actively transferring data, the total available bandwidth is split between them. If one high-speed device, like for example an external SSD, is active on the hub, it will receive almost all of the 5 gigabyte per second bandwidth for itself. So you got to keep that in mind if you're going to be using that. Multiple devices. If you connect and actively use multiple high-speed devices at the same time, the bandwidth will be shared. For example, if 2 devices are maxing out the connection, each may only get 2.5 gigabytes per second. That could cause a noticeable slowdown. So typical use cases like a keyboard, mouse, sharing bandwidth is not an issue because these devices, they don't use much data, like at all. Adding a high bandwidth device, such as a high resolution webcam, it will be best to put that in its own individual port directly in the back of a computer. It can cause slowdowns or lag for other active devices on the hub. To maximize the performances for devices that need high speed, constant data transfer, follow these guidelines. Use separate ports. Connect high bandwidth devices like external SSDs, hard drives, high-end video capture devices. Put those directly to the USB port on your PC, right? Reserve the hubs for the lower power devices. It can still help your computer in, the strain of power supply. Using hubs primarily for low bandwidth devices like your mouse, keyboard, printer, or charging cable. Get a high-speed hub. If you must use a hub for high-speed devices, choose one that supports a faster standard like USB 3.2 Gen, 10 gigabytes per second, or Thunderbolt up to 40 gigabytes per second. This will give you more total bandwidth to share, but keep in mind you have power supply from your monitor, then you have power supply being used by a graphics card when you're gaming, and power supply limited by your PC power supply. If you're sharing bandwidth to transfer data, using such hub will not take away from your PC because it's separate from the internet bandwidth. So if you're live streaming, however, even though it won't affect your internet bandwidth, it could affect your other bandwidth. Sharing USB bandwidth can cause problems for your live stream if you use USB devices that require high data transfer rates, like a high-resolution webcam or a capture card. It could have frame drops. A 1080p or a 4K webcam constantly streams a high volume of data through the USB hub. So again, plug that directly into your PC. Now, if you're transferring large files from an external hard drive on the same hub, the hub's shared bandwidth can become saturated. It could cause the webcam to lose data, and that would result in stuttering video or dropped frames. It could. The audio and video sync issues, data congestion on the hub can cause your audio and video streams to become out of sync. That could create a disjointed viewing experience for your audience, if you have an audience, right? Input lag. Latency can increase when multiple devices compete for bandwidth on the same hub. This can be problematic if you use high-performance USB peripherals like a gaming mouse or keyboard. That's right, not all mouses are equal when it comes to using power supply. So here's what you can do to avoid USB bandwidth issues while live streaming. Plug your high bandwidth devices directly into the PC, like I said. Your webcam, your capture card, your high-speed storage directly into a dedicated USB port on your PC. So that will bypass the hub entirely. Just use the hub for low bandwidth devices, like your keyboard, mouse, or headset. Spread the devices across different controllers. On most motherboards, a set of adjacent USB ports, like, for example, ports stacked on top of each other, they share the same internal USB controller, and so they have the same bandwidth. So if possible, plug your high priority devices into separate, non-adjacent USB ports on your PC so they can have their own dedicated bandwidth. Use a high quality powered hub. If a hub is necessary, always use a high quality externally powered model. So a powered hub can ensure consistent performance and prevent power related issues that can cause device instability or failure. Now, when it comes to recording gaming, let's say you're not live streaming. Let's say you record videos and then you edit them and share them later, right? So when you're just using software to record game locally, your USB bandwidth is still a critical factor, and it's handled differently than during a live stream. You could get a saturated USB hub that could be even more severe because local recording demands a higher, more consistent bit rate than streaming. Live streaming compresses video to match the bandwidth of your internet connection. Local recording uses a much higher bit rate to preserve the best possible video quality. Of course, you can control the settings, right? All of this high bit rate data must be transferred over USB from your capture devices to your PC and then written to a storage device, potentially over the same hub. So more demanding data transfer, the recording process is a constant high-speed data right to your storage drive. So if your game footage is coming from a capture card and your storage drive is plugged into the same USB hub, those two devices are competing for bandwidth on the same 5 gigabytes per second pipeline or whatever that you have. The increased risk of frame drops. So in a local recording scenario, a bottleneck in USB bandwidth is more likely to cause severe issues like dropped frames. When the video streamed from your webcam or your capture card cannot be delivered to the recording software fast enough due to the shared bandwidth, the software will drop frames to keep up. That can result in stuttery, non-fluid footage. While you may not have to worry about your internet upload speed because you're not live streaming, if your USB peripherals and storage drive are all routed through a single hub, you just move the bottleneck from your internet connection to your USB connection, basically. So how you can avoid these issues during local recording, just plug the high bandwidth devices directly into your PC, like your webcam, capture card, or your external SSD, so they can have their own dedicated ports on the back of your computer, never the front. Check your motherboard's USB controllers because many motherboards group adjacent USB ports on the same internal controller, so they share the same bandwidth. To give your high bandwidth devices the best performance, plug them into ports that belong to different controllers. You can find this information just by checking your motherboard's manual or just look into your Windows Device Manager under Universal Serial Bus Controllers. Reserve the hub for low priority devices, like your keyboard, mouse, headset with their very low bandwidth requirements. They are perfect candidates for sharing a single USB hub, and that will free up your computer's high-speed ports for your recording critical hardware. I always use an internal SSD, but for those that don't, if you're recording to an external drive, even a fast SSD, it still depends on the USB bus. Recording directly to a fast internal NVMe or SATA SSD will eliminate this potential bottleneck altogether. So, can a limited power supply of a PC help with an external power hub when it comes to the demand of a graphic card? And the answer is no, because an external powered USB hub cannot help a graphics card that needs more power than the PC's power supply unit can provide. A graphic card draws its power directly from two sources, neither of which involves the PC's external USB ports. The motherboard's PCLE slot, this provides up to 75 watts of power. Dedicated power cables from the PSU, high power cards use 6-pin, 8-pin, or 12-pin cables that connect directly from the card to the PSU. So why a USB hub will not work? Even one with its own power source can't transfer power to the graphics card for these reasons. Different power circuits. The power delivered through a USB hub is on a completely separate circuit from the one that powers your PC's internal components. The USB hub provides power only to the USB devices connected to it. Wrong connection type. A USB hub provides power through a USB cable. A graphics card uses entirely different, much more powerful cables and connectors to get electricity from the PSU. Insufficient power. A USB connection, even a powered one, cannot deliver anywhere near the amount of wattage a modern graphics card requires. Many gaming graphics cards draw hundreds of watts, which is far beyond the 7.5 to 20 watts a USB hub can provide. So if your graphic card is not getting enough power from your PC's power supply, the only solution is to replace your current PSU with one that has a higher wattage and can handle the total power draw of all your computer's components. A graphic card that is underpowered can cause serious problems. Now keep in mind what you see as far as the data on your screen is not always going to be what's actually happening with the power transfer. And I'm going to go into that in a minute. System crashes. Your PC may shut down suddenly when the graphics card is under heavy load, like when you're gaming. Boot failures. The PC may fail to boot or show a black screen if the PSU cannot deliver enough power during startup. Damaged in components. A low-quality PSU that is overloaded may fail to properly regulate power, potentially damaging your motherboard, your CPU, and your GPU. Please be aware of this when you see things like, oh, but the data on the screen that's showing GPU, CPU, frames per second, it's not showing any issues when you add a higher demanding graphic card. Well, the on-screen display of CPU, GPU, and frames per second can be misleading. It doesn't show the underlying power draw and regulation issues. So the PC may seem to be working, but it's operating on borrowed time. Now, a lot of people have done this and not had any issues. But over time, it can cause problems. System instability and crashes. Under heavy load, such as during gaming, the graphics card can demand more power than the PSU can supply. A quality PSU safety features will trigger, instantly shutting down the computer to prevent damage. With a low quality PSU, it may simply crash. Sometimes you'll get the blue screen. Reduced performance throttling. Some hardware is designed to detect insufficient power, and I've seen some people like bypassing, devices, power supply, preservation, if you will, which can only cause more problems. They're designed to detect insufficient power, and it will reduce its clock speed to compensate. That's known as throttling and results in lower frames per second. You could lower your settings, lower your frames per second, if you have a limited power supply to get safer for your results, if you will. So if you have lower frames per second and an inferior gaming experience, basically you're not getting the performance you paid for, right? The worst case scenario with a cheap, underpowered PSU is that it lacks proper safety features. And for me, like a lot of people, they just bypass safety. Like, well, I haven't really had any issues, or, for me, I just rather do it in a safe way. That's how I roll, right? That's what I try to do. So a cheap, underpowered PSU lacking safety features, or the proper safety features, if you will, it can cause, so this is where you're putting the risk in there. It can cause voltage fluctuations that damage the GPU, the motherboard, or other components. The PSU itself could overheat, could burn out, and potentially take other parts of your computer with it. Then there could be power spikes. Modern high-performance graphic cards are known for having transient power spikes, where they demand exponentially more power for fractions of a second, an undersized PSU won't have the headroom to handle these spikes, which could lead to system crashes. So the on-screen display that shows the CPU, GPU usage and frames per second at a particular moment doesn't reveal the critical details of power delivery. Please keep that in mind. The display doesn't show that the GPU may be underclocking itself to stay within the PSU's limits. It doesn't show the sudden power spikes that lead to a full system crash. It doesn't show the strain on the PSU, which could cause it to fail completely over time. So the bottom line is, if you're attempting to run an underpowered graphics card on a weak PSU, it's a significant risk with no long-term benefits. It's like putting a sports car engine in a compact car. It might seem to work for a moment, but the chassis isn't built to handle the strain, and it will eventually break down. So the only safe and correct way to ensure a high-end graphics card works properly is to pair it with a PSU that meets or exceeds the manufacturer's recommended wattage. Also keep in mind when using an external power hub, like a lot of people think that, okay, your computer has, let's say, maximum 8 ports. You got like, I don't know, maybe a couple in front, maybe 4 in front, 4 in back, and then you can't just like make your PC that was built with 8 ports or limited amount of ports and then like double the amount of ports so you can use, more devices. It doesn't really work like that. Making a PC with 8 ports, just for example, have 12 ports by using hubs can cause issues. It's not like it's going to blow up because it has too many ports, right? But the problems can arise from the total bandwidth and power that has to be shared across all devices connected to the same USB controller. All the ports on a single USB hub, and often several adjacent ports on your PC itself, are connected to the same internal USB controller. So that means they all share a single pipe for data flowing to and from the PC. So for example, type of device, low bandwidth, mouse, keyboard. Multiple devices can share a hub with no noticeable performance issues, but the higher bandwidth ones like your external SSD, webcam, you can have a severe bottleneck that can occur if multiple high bandwidth devices are used simultaneously on the same hub. Slow data transfers, drop frames, video lag, for example. Even if your devices don't use much bandwidth, they still draw power. So unpowered hubs. A standard USB port can only provide a limited amount of power. Using an unpowered hub with multiple devices, especially high-power ones, can cause the hub to fail or cause devices to randomly disconnect as they don't receive enough electricity. So if you get that message that you're having a power supply issue, probably wouldn't be a good idea to go in and then just bypass the power on a port or a device. You're getting the message for a reason, right? The hub topology and limits. The USB standard supports connecting a large number of devices, up to 127 in older specs, more newer ones, to a single USB controller through hubs. But this theoretical maximum is far higher than what is practical. Each hub itself counts as one of the connected devices. Your PC's motherboard may have several internal USB controllers, so spreading your hubs across different root ports can help manage the load. So here's a practical example. Imagine you have an 8-port PC and you add a 4-port hub. You plug your mouse, your keyboard, your printer into the hub and your external SSD into a direct port, and everything works perfectly. But the worst case scenario is you plug a 4K webcam and external SSD, a multi-format card reader, and external hard drive into the same hub while you're gaming and recording footage to the SSD. The footage will stutter because the webcam and hard drive are competing for the same limited bandwidth. So adding more ports with a hub is fine as long as you're mindful of how you distribute your devices. Bottom line. Anyways, I hope maybe somehow or another this has been helpful to somebody. And I know there's a lot of people work with computers and do different things, and they're like, maybe they won't agree, but I just prefer to take the safer route, get the most longevity out of my computer and not put it at risk in any way. Hope you have a blessed day. Bye.